In this video, I would like to show you how to do hypothesis testing about a population proportion. So to do that, we need to estimate the test statistic, which will be the z-score. And to estimate the z-score, we need the sample proportion, from which we subtract p0, which will be the hypothetical value of the true population proportion, or the value of the proportion specified in the null hypothesis. Q0, as always, is calculated as 1 minus P0, and N is nothing else but just the sample size. Here is the quick summary of the three possible tests: negative-tailed, positive-tailed, and two-tailed test. As you can see, the null hypothesis, as always, is some equality, and it is the same for all the three tests, that the true population proportion is equal to the hypothetical population proportion. As for the negative-tailed test, the alternative hypothesis is when the true population proportion is below the hypothetical population proportion, and we reject the null hypothesis and accept this alternative hypothesis when the estimated z-score is below the critical critical z-score at the level of significance alpha. As for the positive-tailed test, the alternative hypothesis is when the true population proportion is higher than the hypothetical population proportion, and in this case, the null hypothesis is rejected and the alternative hypothesis is accepted when the estimated z-score is higher than the critical z-score at the level of significance alpha. And the two-tailed test has the following alternative hypothesis: that the true population proportion is not equal to the hypothetical population proportion, and we reject the null and accept the alternative hypothesis when the estimated z-score in the absolute terms is higher than the critical z-score at the level of significance alpha divided by 2. Let's have a look at the example. So a manufacturer of some batteries may want to be reasonably certain that less than 5% of his batteries are defective. Suppose that 300 batteries are randomly selected from a very large shipment, each is tested, and 10 defective batteries are found. Thus, this outcome provides sufficient evidence for the manufacturer to conclude that the fraction defective in the entire shipment is less than 5%. Use 1% significance level. So, based on this information, first of all, we can calculate the sample proportion. So 10 defective batteries out of 300 batteries will give us the proportion of 10 over 300, or 0.0333. So the proportion of defective batteries in the total sample of 300 batteries. The hypothetical population proportion that we would like to work with, that we are asked to work with, is 5%, because we want the proportion of defective batteries to be less than 5%. So P0 is 5% or 0.05. We can get the value of Q0, which will be just 1 minus 0.05, 0.95. The sample size is 300 batteries, and the significance level is 1% or 0.01. First of all, we need to formulate, as always, the null and alternative hypothesis. So the null hypothesis is always some equality, and in this case that the true population proportion is equal to 5%. And the alternative hypothesis, since we want the proportion of defective items to be less than 5%, the alternative hypothesis will be that the true population proportion is below 5%. So we use 1% significance level, and this is a negative one-tailed test. So we get that the critical z-score for 1% for a negative one-tailed test will be negative 2.33. After this, we calculate the z-score. So we substitute everything into the formula. Instead of p with the hat, we put 0.033. P0 is 5% or 0.05. And in the end, we get that the z-score is equal to 1.32. After this, we need to make the decision about whether we should reject or accept the null hypothesis. So, since the estimated z-score of negative 1.32 is higher than the critical z-score of negative 2.33, we cannot reject the null hypothesis. Therefore, we conclude that there is insufficient evidence at the 1% level of significance to indicate that the shipment contains less than 5 defective batteries.